take a look at today's Do Now. Today we will be able to solve quadratic inequalities, and we'll be able to explain the process when solving a quadratic inequality. So let's take a look at today's Do Now. Let's take a look at today's Do Now. Find the x-intercepts of the function f of x equals 5x squared minus 27x plus 10. So pause the video, find the x-intercepts. Alright, so your x-intercepts or solutions are x is equal to 5 and x is equal to 2/5. Let's look at today's thinking. How do we solve quadratic inequalities? When asked to solve a quadratic inequality, we will need to use our knowledge of solving a quadratic equation. The steps: set the inequality to 0. Factor if possible. Set each factor equal to 0 to obtain critical numbers. Place the critical numbers on a number line. Use interval testing. And write your solution using interval notation or any other notation that they have asked. Let's look at example number 1. Solving a quadratic inequality. Given the following, -3 is greater than or equal to x squared plus 4x. We want to solve the inequality. We want to find the solutions using interval notation, and we want to graph the solutions on a number line. So let's start off by solving the inequality. In order for us to solve this inequality, we are going to set the inequality to 0. But before I do that, I am going to rearrange the inequality right now. So I want it to be where the ax squared plus bx piece is in front. And we are going to set this equal to 0 by moving that -3. So we do want it to be in standard form. At this point, we are going to factor this and just make that inequality an equal sign for now. Now, if this was an equation, my two roots, my two x-intercepts, or my two solutions would be x is equal to -3 and x is equal to -1. But we did not have an equal sign, we had an inequality. So here is where us placing these critical numbers on a number line are going to come in handy. So I am actually going to be doing part C here. What we want to do is we want to pick a number that is below -3. So I'm going to pick a point on the left side. So what number is less than -3? I will say x is equal to -5. Any number will work. What we are going to do is we are going to input that value into our original inequality and see if it comes out true. And -5 does not work because I have a statement that says -3 is greater than or equal to 5, which we know is false. That means that that value is not part of my solution. What numbers would be part of my solution? Any number that is on the opposite side. So I do have my first inequality. For x is equal to -3, as we got, our x values are actually greater than or equal to -3. So why or equal to? Because our inequality did have an or equal to piece to it. So that is one of my solutions. Let's find another solution. So I am going to look at the next value that we got, which was -1, and I am going to pick a number below it. So let's pick a number here. I'm going to choose a value of 0. And I'm going to do the same thing by testing that x value into my original inequality. and I end up at -3 is greater than or equal to 0. Is this statement true? I picked 0, so it's on this side actually. Is this statement true? No, this would be a false statement, which means that my answer would be somewhere below -1. So I have x is equal to -1, but x has to be less than or equal to -1. So let me graph this. The first piece here, we were dealing with, it will be including in all numbers that are greater than -3. For our second solution, we found x is -1 and all numbers less than -1. Our answer is going to be the intersection of those two pieces, the double squiggle. So in this case, that piece there. For part B, my solutions are from -3, including -3, all the way to -1, including that value. Let's look at number 2. So here we have let f of x be less than or equal to -x² plus 2x plus 3. Find the solutions of f of x using interval notation. Graph the solutions on a number line and sketch the graph of f of x is less than or equal to 0. Alright, so let us start by finding these solutions. Before I do anything, I'm just going to rearrange my function. I'm going to set this equal to 0, and I'm going to solve using my factoring skills. And that leads me to x is equal to 3 and x is equal to -1. Those are our critical points. I'm going to put this on the number line and figure out where my inequality actually falls. So again, I'm going to pick a number to the left of -1. I'm going to test that value into this function here. I get that -32 is greater than or equal to 0, which clearly is false, which means that my first possible answer would be x is greater than or equal to -1. And I'm going to graph that. All right, so let's test out what happens at 3. So I'm going to pick a number I'll pick a number in here. I'll choose 0. And I get 3 is greater than or equal to 0, which is true, which means that my solution lies somewhere in there. My solution is the intersection, the double squiggle. And we want to represent our solution using interval notation. So I am going to say from -1 to 3, including those values. Part B, I already did. I sketched it on my number line. And now part C, we want to sketch the graph of f of x is less than or equal to 0. So to sketch this quadratic, we are going to still need all of the main things we need for a regular quadratic. I am going to need the roots, the y-int, the axis of symmetry, and the vertex. Okay, so let us graph our parabola as we have been already doing. All right, so here's my parabola. I'm gonna label my points. Now, quick thing, we did have our inequality, and our inequality was an or equal to, so my curve is a solid line. Okay, so here we have our quadratic as we have seen in the past, but we are dealing with an inequality. So what I need to do is I need to pick a point. I need to pick a point that determines where I'm going to shade, because when we are dealing with inequalities, we're dealing with shading a region of points. So I am going to pick the easiest point to work with, 0, 0. And I'm going to input it into my function to see when this piece will be true. So here is my side work. So we have f of x has to be less than or equal to 0. So if I input, so is the value 0 less than or equal to 3? Yes, which tells me that we are going to be shading towards that point. If it would have come out false, then we would have been shading away from that point. So all points outside of that parabola. And this was my f of x, and this was my original function piece. So I input the value of 0 for x and 0 for f of x or y. Let's try another one. Let f of x be greater than 2x squared minus 9x minus 5. We want to find the solutions for f of x using interval notation, graph the solutions on a number line, and then sketch the graph of y equals f of x. So what we are going to start off with is I am going to rearrange my parabola. So I have that standard piece in front. At this point, let us start using our factoring skills to factor this and find the roots or critical numbers. All right, so we have these possibilities. For part B, since I'm going to need to graph it, I'll put it on this side here. We have the number -1/2 and the number 5. I am going to pick a number right here to the right of -1/2. Let's pick a nice easy number, x equals 0, and test that value into our function to see if it comes out true. So I get it to be -5 is less than 0, which is clearly true, and that means that x must be greater than -1/2, not or equal to. Why not or equal to? Because we were dealing with just a less than symbol. So I am going to go to my number line, not included, and all numbers that are greater than. Now for the number 5, I'm going to do the same thing. I am actually going to pick a point to the left. And if I just stop and think about this, a number to the left of this would be 0, and 0 does work out because we did test it out already, which means that 5 is not included, and all numbers to the left would be. X must be less than 5. So my solution using interval notation starts at -1/2, not including -1/2, and goes to 5 and does not include that value as well. All right, so we are done with part A, done with part B. Part C wants us to sketch the graph of y equals f of x, which means that I am changing that function from an inequality to a regular parabola. An equal to. So in order for us to graph that, we will need the key features. Roots we already have. We have it at -1/2, 0, and 5, 0. The y-intercept's easy to find, 0, -5. The axis of symmetry and vertex I will need to find by using the formula for the axis of symmetry. So the axis of symmetry turns out to be a 9/4. I'm going to plug that value into my function and see what is the vertex. At this point, what we are going to do is we're going to graph it. Again, it's a regular one they wanted us to graph, y equals, so my parabola is just the normal style that we have seen. And I am done. Now, if they ask me to graph the inequalities parabola, my parabola would look something like this. I will put it on the side here. This is not asked, but if they ask me to graph the inequality, the f of x is greater than, my parabola will look pretty much identical with all those same key features. As identical as I can do it, but a few things will occur. First, the inequality that has been given is a greater than, which means that my parabola would be broken. So a dashed parabola. Pick a test point. My favorite test point is the point 0, 0 if possible, and I will plug it into the function and see if it comes out true. If it comes out true, that means that is where I'm shading. And 0 is definitely greater than -5, which means I will be shading towards that point. So my parabola will look something like this, again with all the labelings as well. So keep learning, keep growing, and I will see you in our next video.